Hey guys, so we're going to talk about, oops, I left this from the last one, sorry. We're going to talk about transformations here, and this is the fourth video in the set of transformation notes. You only need to watch this one video, and you should get the other information from the other groups, but you can, I will post all these videos and notes so you can go back and watch them if you'd like, if you missed something. So your learning target is 4G. I can perform transformations of parent functions, and we're going to focus on reflections for your group. So we last class learned about all the different parent functions. Those are like your mama and your papa functions. Those are the basic standard functions centered around 0. And all the things we're going to do today are going to be to change that particular function, and we're going to end up with something that resembles the parent function, but it's a little bit different, okay? So all functions are based off of the parent functions. And we're going to start with the parent function, and then we can perform transformations. There's 4 different ones that we're going to perform to change the function. This particular transformation is called a reflection. All right. There are 2 types of reflections. The first being a reflection over the x-axis. Right? And you might remember this from geometry. You guys did this with shapes back in geometry. Reflection is the same idea as a flip. Right? So we're going to flip, back in geometry you would have reflected a shape. We're going to do this with functions though. So we're going to flip a function over the x-axis. And we do that by putting a negative in front of the function. So a negative sign in front of whatever function it is that we have. All right. The other type of reflection we can do is a reflection over the y-axis. And we do this by putting a negative number inside of the function. So inside of whatever symbol it is that we have, if it's just a general function and we don't know the actual equation, we can just put it right inside of the parentheses there. All right. So let's apply this to a couple different ones. So first, let's apply this to a quadratic function. Well, remembering what the quadratic equation is, when we know it's a parent function, we just want f of x equals x squared, right? First directive is to reflect over the x-axis. So I'm going to do that by putting a negative in front of the function. So we could do negative f of x, or if we know the function like we do here, we can do we'll start with f of x equals, and then do negative x squared. All right, so let's pull up Desmos and just watch what happens as we do that. All right, let me get rid of that. So we start with x squared, that's our parent function, and then if I do negative x squared, well, look where that graph went. It flipped over the x-axis. So it was facing up, now it's facing down. Another way I like to think about it is if there's a positive number in front of your function, it's positive. So it's a happy, smiling parabola. If there's a negative number in front of your function, like we have here, it's very negative. So it's a sad, grumpy parabola. So it's making a frowning face. So negative is going to make it flip upside down and look like that. All right. The next directive is to reflect it over the y-axis. So we could then put the negative inside of the function if we didn't know it. But because we do know it, I'm going to say f of x equals, and then I want parentheses so that, remember when we did the exponents, so that that exponent gets applied to both the negative and the x. So negative x squared. So watch what happens when I change this slightly and I put a negative inside and square it. Well, that function there, the black function, looks the exact same as the green parent function, right? Because this is a reflection over the y-axis, right? So if you think about this parent function right here as being the parabola, if I flip that over the y-axis, because it's symmetrical, these points are the same distance away from the y-axis as these points, when you reflect it, they're really in the same place. Okay, so we don't actually see a change there with a graph that's symmetrical over the y-axis for that very reason. But we still technically did the reflection. Let's try it for an absolute value function. So absolute value, remember, is absolute value symbol, x inside. And we want to reflect it over the x-axis. So here we would have f of x is equal to, and I'm going to put the negative in front of the absolute value symbols to make that reflection happen. So parent function there makes the V shape. If we put a negative in front, oh look, it flipped right upside down. Okay. And then lastly, the square root function, f of x equals the square root of x. If we want to reflect this over the y-axis, then we want that negative to be inside of the function. So f of x is equal to the square root of negative x. So when I say inside the function, I mean inside of the symbol. Okay. Now watch what happens on our graph. Square root of x, square root of negative x. Oop. So the green one, move it out here a little bit, is the parent function. The purple one is that parent function that's been reflected over the y-axis. So we actually see it flipping over that y-axis there. All right.